Okay, so you should have one valence electron. And then one fact about that would be they're reactive. They have one valence electron, and they're like soft metals. Next up, we have the alkali earth metals. Similar name, slightly different behaviors. So this is the second column, second family. They're called the alkali earth metals. They're silver and more dense than the alkali metals. They're pretty reactive, but just not as much as the alkali metals. And they have two valence electrons. Two valence electrons. Okay, so again, should look like this. Now, the a good example of this is magnesium versus sodium. Magnesium powder is the stuff that goes on the end of sparklers. Like if you ever had a sparkler on the 4th of July and it sparks that bright white powder, if you scrape it off the end of your sparkler, that's magnesium powder. When it burns a bright white. It's very hot. So it's similar, but not. But that's safe to have in a store in a package. It's safe to hold. Right? They give them to kids. It's safe. But sodium, on the other hand, pure sodium is so reactive that they have to keep it in an oil that's unreactive because it will react with the oxygen in the air. If you throw it in water, it explodes. If it touches any sort of moisture, for that matter, it explodes. So it's very reactive. So there's moisture in the air, so it could react and explode just by sitting there. So that's why I never get to play with it in school because they won't let me have any, which is a bummer, but I understand. So you could look up some videos on YouTube. YouTube has a ton of videos about almost every element. It's actually pretty interesting if you want to see what it looks like and how it reacts. Some are more interesting than others, but it's a good resource if you get curious. All right, transition metals. Uh, these are the largest. This is the largest group on the periodic table. It's got the most elements in it. So the transition metals are very shiny. They're good conductors, meaning they conduct electricity and heat very well. If you look in there, you'll see like Fe is iron, nickel, copper, gold, silver, chrome, titanium. Those are all very good conductors, and they're strong, and we use them for a lot of things in the real world. So we don't make the wires in your house out of magnesium metal because it doesn't conduct as well as copper. Copper is one of the best conductors of heat and electricity, and that's why you see like on those infomercials, you'll see the copper pot, the copper pan. They're like, oh, this one conducts heat so well, it's better than other pans, and it's true because what they're trying to sell you on is that it conducts heat the best, so you don't have to heat your food as much, and it cooks it quicker. So they don't give away electrons very easily because they don't follow the normal valence electron rules. So if you remember from class this year, the valence electrons have to do with the reactivity of the element. So if the valence electrons are low, or they need to give them away, or they're high and they just need to grab one, they're very reactive with things. However, that's not true with the metals. The metals do their bonding from inner layers, so they don't use their outermost valence electron layer to do their bonding, which is strange for elements, so they're not as reactive, but what happens is that allows them to share electrons back and forth, which is why they're very, very good at conducting electricity. So that would be something you can write here. All right, so very here. Someone is calling me in the middle of class. All right, sorry about that. And then they conduct all right. So this is what your note should look like. All right. So for the next slides, these groups are they go from metals to semi-metals to non-metals. The group I'm going to talk about is the green one. Actually, I will do that in a different one this week. Add that to a different thing we do this week. So what this is you got group 13. It's just named after the first element in that group. So group 13 is the boron group. Okay, so boron group. The boron group is group 13. So remember, if you have a number, a double-digit number, cover up the 1, and that leaves you 3 valence electrons. Group 14 is the carbon group. Group 15 is the nitrogen group. Group 16 is the oxygen group. So we have carbon, nitrogen, oxygen, all right, and then if you look at the valence electrons, the 14th group would have 4 valence electrons. 15th group, which is nitrogen, have all of those have 5 valence electrons. And then in the 16th group, all of those have 6 valence electrons. That's all we really need to know about these for now. There's a lot more to them than this. So what I'm going to do with the final lecture of the week is we'll talk about the properties of these and what they do. So until then, valence electrons and just family-wise, this is all you really need to know for now. It should look like this. All right, next up, the bad group on the periodic table. This is called the halogen group. The halogen group is the most reactive elements on the periodic table, so they're very, very, very reactive. They're poor conductors of electricity because most of them are gases. Gases don't conduct electricity, which is why you can plug things in and your outlet isn't shooting electricity out all over the room. Because gases like oxygen and nitrogen and fluorine and chlorine, they don't conduct electricity well. The electrons are too spread out within those atoms to conduct electricity. But they're very poisonous and they're very dangerous because they're so reactive. So they'll react with, living tissue like your skin and break it down because it'll strip electrons away. Fluorine is the most reactive, naturally occurring element on the periodic table. So there are some very, very reactive ones that don't occur naturally. We've made in the lab, but fluorine is the most reactive one. So hydrofluoric acid is very, very dangerous, bad stuff. As an example of an acid, chlorine is used to, clean swimming pools. It's in a lot of cleaning products, like anything bleach has chlorine in it. Bromine and iodine are used in medical settings. Iodine can use to clean cuts and wounds before they do surgery. So if you ever watch like a doctor show, or you see them swab a bunch of like brown liquid all over somebody before they do surgery on them, that's iodine, and it's killing all the germs and bacteria on the surface before they get started. So it's a very, very crazy group on the periodic table. They have 7 valence electrons. All right, they are very reactive. Very dangerous and poisonous. The noble gases are the opposite. They're pretty boring. They don't do much. They have 8 or full valence electrons in their shells. So that means that they don't want to react, which is what makes them so boring. But that's a good thing for us. So they don't react to anything. They are very, very stable. They don't. The whole point of bonding is to go out and get enough valence electrons to fill a shell, or give away enough valence electrons to empty out a shell. So that's why these things react. But if you already have a full shell, you don't need to react to anything. It'd be like having enough money so you don't have to work. So that kind of thing is why they're so stable. They don't need it. Helium is a gas that we use to fill up balloons, and it floats because it's lighter than the oxygen in the air. So it'll float on top of the air. A long time ago, they made a blimp out of hydrogen. Hydrogen is a very, very dangerously explosive gas. Someone lit a cigarette on the balloon, and it blew up. A lot of people died. So they use gases like helium that aren't reactive in situations like that. Also, They use neon to light up signs. They use argon to store other reactive chemicals in. So, for example, francium down on the bottom left corner of the periodic table is a crazy reactive element and will explode if exposed to air. So what they do is they keep it in a capsule that has argon gas in it. And since it's argon, it has a full valence shell. It doesn't want to react to anything. So the francium will try to react with it, won't be able to because the argon will not give up any of its electrons, and it'll stay in the state that the scientists want it to because it's not stripping electrons away like it normally would. Anyone have any questions so far? This is how your notes should be looking with all this stuff filled in. Okay. All right, next up. All right, so on this drawed question, I do want to point something out. So look at my screen. All right, so we are not covering the Lewis dot structures this time through. So don't do this part. Normally I would have you do that because as you move around the dot, you add dots around them and helps you know how many balanced electrons there are. So we're not covering that because this is a condensed curriculum. So I want you to label the rows and the columns. And I want you to put like how many valence electrons each one has. So in row, so this is, I want you to notice that, where is it? There we go. That right here, I'll put in red. Is a break in the periodic table. So we're missing a bunch of columns in between these two. So go ahead, I want you to label the rows and I want you to label the columns on here. So I'll give you about a minute or two to do that. All right, so here's what I mean. I'm seeing a few people submit. So let's change the color. This is column 1. This is row 1, row 2, 2, and so on. So this one right here is boron is 13. That's the 13th column. So again, look at this periodic table that I posted in Schoology. Should help you out a lot. You can see 1, 2, 13, 14, 15, and so on. So as you do that, copy that onto here. So there's more. I want you to do this one, this one, this one, this one, this one, and finish the rows as well. All right, come on, guys. All right, thank you, Jason. You got it right. All right, Amaya, Angelo, Devin, Isaiah, where you at? Terrell.
Okay, so this is my first time. How am I supposed to be doing this?
Okay. Let's see. You're supposed to be on the Nearpod notes, which is on Schoology in the week 2 folder.
Okay.
All right. Did you just join?
Week 2 folder. Near. Say woman.
So there should be Nearpod notes for this. It isn't an assignment.
Oh. We only say periodic table and oh, there we go, periodic table in there part.
Right. So all right. So if we're done with the notes I have for today. So if you're just getting here and you haven't done and you didn't do the notes from earlier, like you weren't here yesterday, then what we're gonna do.
I haven't done nothing because I didn't know I was in summer school.
Gotcha. So right here would be the periodic table notes.
Okay.
So when you click and open that, you'll get a document that looks like this. Now I filled mine out, so that's why it's in red, but it'll be periodic table notes. What you do is you can click on this periodic table Nearpod and then go through the slides and fill in the notes. When you're done, you submit it in this assignment.
Okay.
Okay?
All right.
Let's see. I can throw the notes up for a little bit longer. So if you're stuck, make sure you do that. So while we have a good amount of people in this class, we have 20 people here, which is awesome. So when you go into this stuff, make sure that you are submitting everything on Schoology. My assignments are due on the Saturday of the week. So by the end of the week, as long as you finish it, you'll be good. And yeah, so you just get it to me by the end of the week is good. If you have a conflicting class, I know a lot of you guys have classes that conflict. Make sure that you just send me a text or a Schoology message that says you're not going to be there. And that's fine by me as long as you finish the work. If you need help, you need to schedule it or tell me when you're available. I'm available at 11 every day. If you need help or need to get caught up, just let me know and we can have a video chat and figure it out. So I know there's a lot of people that have overlapping schedules.
Not for me. I only got this in practice. That's it.
Gotcha. All right. Let's see. All right. So if you're following the Nearpod, this is a good one. All right. This one's also good. Angela did a good job. Terrell, I like how you went through and typed them. All right. So
I forgot to put the 3.
It keeps saying, "Oh snap, your answer is unable to be submitted."
on